Hello, let's do the New York Times Medium Sudoku for May 13th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. I assume very little Sudoku knowledge for the solve of my medium as a teaching aid. We're also going to take a very systematic approach to the solve. So let's go over some terminology first. First of all, each of these little boxes is a cell. We call them cells to distinguish from box, which we call something else. So there's 81 cells in the grid. It's a 9 by 9 grid of cells, so there's 81 in total. And each cell will end up with a digit placed in it. We are given some of the digits to start. That's what makes the puzzle. There's only one solution to every Sudoku, so we can solve it logically. Because there's only one solution, we can arrive at that solution logically, which means whatever this cell is, there is only one value it can actually be and allow us to lead to a solution to the whole puzzle. So we're not going to be guessing. All right, so also we have rows, we have columns, and we have boxes. A row is a row of a horizontal line of cells, a column is a vertical line of cells, and a box is a 3 by 3 region of cells. The boxes are just the ones that are bold outlined here, so there's 9 of each. Now, within each row, column, and box, we are placing the digits 1 to 9 exactly once each. So we cannot repeat the digits, and we cannot omit a digit. That's going to be very important to our logic. And then finally, we have bands, which is a row of 3 boxes. That's just a convenient way of referencing that structure. And stacks, which is a column of 3 boxes. Again, just convenience. Of course, if you rotated the grid 90 degrees, if you rotated the grid 90 degrees, then your bands and your stacks would swap, your rows and columns would swap. So they're all fairly equivalent to each other, but we do need names for these structures that we're using. All right, so we're going to get started, and the way we get started here is by looking at the bands first. So we're kind of focused on just what the bands are telling us to start with. There's 3 bands in the puzzle. We're going to go 1, 2, 3. We're going to do the same thing to each. Now, if you think about a band, how many of each digit does the band have? And it's not a trick question. It's a pretty easy question. The answer is there's 3 of each digit, because there are 3 rows in the band, and every row will have 1 of each digit. So we're going to have 3 of each in total for 3 rows. Okay, so what we're going to do is we're going to look for digits in the band that appear twice, but not the third time yet. And the third location for that digit will therefore be extremely restricted. And that'll help us get information about the puzzle. We're going to seed the puzzle with as much information as we can as we go through it on our first pass. And then if we need to do a second pass, that'll help us analyze further. So how do we find where a digit repeats? Well, I recommend comparing box to box. There's 3 boxes. We need to do 3 comparisons. Box 1 against box 2, box 1 against box 3, and box 2 against box 3. I recommend starting with the box that has the fewest givens, which happens to be box 1 today. So we think about 6 and 9. Then we just look at these 2 boxes, and we see if there's any other 6s or 9s. And we see that there's a 9 here. There's no other 6, but there is a 9. So now let's think about the consequence that has on the box that still needs a 9. This box has a 9, this box has a 9. This box will have 1, but it doesn't have it yet, so let's find out where it goes. Well, this 9 here says it can't repeat in the row, so not here. And this 9 here says can't repeat in my row either, so it's not here. And in addition to that, we have a 5 in this cell, which says you can't put a 9 here, there's already a 5. And this is where we peek down just briefly into other bands. We see we have a 9 down here, which takes 9 out of that cell. So as a result, this is the only cell in the entire box that can be 9. We call that a hidden single, because hidden within the box, we have found that there is a 9. There's only one place for 9, a single cell that can be 9. And so that cell must be 9, because we know the box is going to end up with a 9, and this is the only cell that can end up a 9, so it will. So that's perfectly logical. All right, so that was the 9. Now we compare these 2 boxes against each other. I picked the one with the fewest givens, 2, 3, 7, 9. We have the 2 and the 7. We'll do them one at a time. These 2 2s look in here. So 2 is in one of these 2 cells, and down here we don't have any 2s to help. So 2 is in one of those 2. We're going to use corner marks to remember that 2 ends up in one of those 2 cells. Whenever we use corner marks, that's always going to mean that within the box, those are the locations. That's the list, comprehensive list of cells that can have that digit. We're only going to mark if we're down to 2 or 3 locations in the box. And with 3 locations, we're only going to do it if they're all in a line. So it's completely column or row. And for 2, we do it wherever. And that's just to keep us from misscanning stuff later. We also have these 7s. They look in. 7 ends up in one of these 2 cells. All right. And so those are all of the repeated digits in this band. Before we move on, there's two things I want you to look for. The first thing is a completely filled box row. We don't have any of those. But let's say this was filled with a 1 for some reason. This would be a filled box row, but we don't have that. So no filled box rows. And then secondly, we want to look for rows or boxes that have been reduced to 4 or fewer open cells. So for example, this row has only 4 cells remaining. That means there are only 4 digits that the row still needs. They are the 1, 5, 7, 8. So we want to think about 1, 5, 7, 8. Now the first thing that I'm seeing, and this takes a little practice to notice, but the 5 can only be in one of these cells. Notice this 5 here says not here, this 5 here says not here, and this 5 here says not here. And so in this entire row, there's only one cell that can be 5. That is a hidden single in the row. Remember, this 9 was a hidden single in the box. This 5 here is a hidden single in the row. The row is going to need a 5. This is the only cell that can be. So we can place that 5. Now, when we did so, there was a corner mark 7 in there that's no longer there. So now we've reduced the 7 in this box to being only in one location in the box. So we place that 7. That's a hidden single 7 in the box. Also in the row, if you prefer. And so that leaves 2 digits for this row. We need the 1 and the 8. And we're looking for 1s and 8s. We don't see any. But it would be really nice to be able to remember that these cells individually are down to just 1 and 8. We're going to use center marks for that. The Sudoku Pad software I use supports both corner marks and center marks within the same cell, which is very convenient, so that we can use 2 different styles of marking. So the center mark is going to mean that this cell has been reduced, its list of candidates, right? So the digits that could be in this cell, the comprehensive list is center marked, 1 or 8 only. This is also going to be 1 or 8 only. And that center mark is going to help us remember that. It's also going to help us find pairs and triples. Okay, so that was quite productive. We got that 5 and 7. Now, this filled up a box row. So what we want to do is we want to do what we would do with box rows. I haven't explained it yet. What we do is we look at the 2 rows that aren't the row in the 2 boxes that aren't the box. So it's going to be 12 cells. We're going to ignore any empty cells, and we're going to look at anything that's not already placed in the box. 7 is placed. 7 is placed, 5 is placed, 9 is placed. So just the 2. Now notice what that 2 does. It does reduce 2 to these 2 cells, but we already have it marked, so we're not worried about it. So that's all we can do with that. All right, so now we're back to looking for, we also want to find buddies. We want to make sure we look for duplicates of the 5 and 7 that we placed. The 7 we already have 3 of, but the 5 we do not. So these 5s look into here. This 5 looks up, and so 5 ends up in one of these 2 cells only. All right, so now we look for additional 4 or fewers, and this box is down to 4 or fewer. So let's think about what the digits are. There's 4 of them. We need 1, 3, 6, 8. So I'm seeing we have this 6 here, looking in, saying these 2 aren't 6, and then this one's also not 6. You can either reference the center marks or you can see why, which is the 6 over here. That means there's a hidden single 6 in the box. We can place it. The remaining digits are 1, 3, 8. Now I am willing to mark that, 1, 3, 8, because I'm willing to center mark a cell if it is down to 3 or fewer. If it has 4 or more, I don't recommend center marking it. But the other thing I notice here is that actually 3 is limited to 2 cells. We can corner mark that. Now that is going to do something called pointing. So what has happened is in this box, box 3, we have reduced the 3 to only 2 cells. And these 2 cells have something in common. They are both in column 9. And so that is also going to be the 3 for column 9, because one of these will be 3. Whichever one is 3, it will be the 3 for column 9, meaning the rest of column 9 cannot be 3. So we've eliminated 3 from all of these cells. That doesn't do anything immediate, so we're just going to have to try to remember that. That's what the corner mark tries to help us with. All right, so that was this box. We did get a 6 and a 9. The 9s are done, but the 6s are not. So this 6 looks into this box with this 6. These aren't 6. Let's just place this 6. Very nice. By doing so, this filled up. This box row filled up. So we do want to reference these. The 5 we already have marked in here. 6 is placed, 7 is placed, 9 is placed. This 1, 8 doesn't help, neither does this. The 2 is placed, 7 is placed, 6 is placed, but 4 is not. So actually we can see that 4 is reduced to one of these 3 cells. And in general, this box is down to 1, 4, 5, 8. So this one is down to 1, 4, 5 because it can't be 8. This one can't be 5, so it's 1, 4, 8. And this is any of 1, 4, 5, 8, so we're not going to mark it because it's down to 4. but we do see that the 4 and the 5 are here. So this 4 does something special. It does pointing, just like these 3s did. We know in this box, the 4 is in one of these 3 cells, which are all in row 2. So these cannot be 4 because the 4 is over here. So if these are not 4, that means the 4 is down here somewhere, not here, because this 4. So that's very handy. All right, now this row is also down to 4 or fewer. You don't always get this much out of it, but we want to keep at the band until there's nothing left to find, and then we move on. So we need 1, 3, 4, and 8. Excuse me. So I see that neither of these are 1, so this is down to 3, 4, 8. And this can't be 4, so this is 1, 3, 8. All right, and I think that's all we get out of that. So I think that's it. That's it for the band for now. Let's move on to the next band. So I'm going to start here, the 1 and the 5. We do have a buddy for the 5. This 5 also looks down. That places a 5 here. Okay, nobody for the 1. The 8 and the 5, we already took care of the 5. We have this 8, nobody there. Okay. Is there any filled box row? Is there any row or box down to 4 or fewer? Answer to both is no, so we can just immediately move on. Down here, I'm going to start with the 5, 9, nothing there. 3, 7, still nothing. So no buddies at all. Look for filled box rows, nothing. Look for 4 or fewer open cells, nothing. So we found a lot less there. I do want to point out something that you may or may not notice, which is these 7s. I will show you how to find that if we do a second pass. But it is very useful. If you happen to notice it, there's no reason not to use it. I'm going to skip it as if we didn't notice that, but that is something to look for. But it isn't isolated to just this band in a way that's helpful to scan for that band. So we're trying to pick the low-hanging fruit off first. But if you do happen to see something like that, it is quite helpful. All right. So now we're going to do the exact same thing we did with bands, but we're going to do it with stacks. And anytime I say row, I'm going to say column instead. So we're going to start with this 1 and 5. We do have 2 1s looking up. That does place 1 in this box. 1 can only be there. So that means this can't be a 1. Is there any other follow-up here? I don't think there's any other follow-up for this 1. It does make this box down to 4 or fewer, but we're going to cover that when we do get that to that part in the stack, so I'm not worried about it. We'll get there. We also have, let's see, we did the 1, the 5. We have this 5 up here, and we have this 5 looking in. So that places this 5 here. Now, we already scanned this band, but we have new information, this 5. So we want to see what that does, and that does place the 5 here. Now, that removes this 5 corner mark. Now we look in this box and we see there's only 1 5 corner mark remaining, so that is a hidden single 5 and we can place it. Very, very nice. I also noticed that 8 has been reduced to these 2 now, so those are going to point. And we can see the consequence of that now. It's going to cause an 8 to be in one of these 2. With pointing, I always recommend following up with whatever you can, because it's really easy to miss later. Okay, so we got the 5, the 1, so we did the 1 and the 5. I'm going to look at these 1, 2, 4, 5. So the 1 we took care of, 2 and 4, there's nobody. So that is it for that. Did we fill up a box column? This is actually filled, but the 1s and the 5s are already in the box. This column is down to 3 digits. We'll start with that. We have 1, 2, we need 3. I'm going to fill it just because we know that they're all worth center marking because it's down to 3. So we need the 3, we need the 6, and the 8. So we know this isn't 3. Oops. We know this isn't 3 and this isn't 8. That means the 3 in this column is limited to these 2 cells here. The consequence of that is called claiming. It's very similar to pointing, but it's kind of the opposite way. So this column needs a 3, and it's limited to these 2 cells. And those 2 cells happen to also be in the same box, in box 4, which means that this is the 3 also for box 4. The column has claimed the 3 from the rest of the box, which means these cannot be 3. All right. Another thing I want to look for here, and I am noticing it, and this is going to be extremely helpful, so we're going to do it now, which is that when you fill up 4 like this, where there's just 1 row and 1 column left in a box, this is a kind of a rarer case that'll happen. Notice that there's still 2 rows and 2 columns. Even though there's a bunch filled, there's 2 rows and 2 columns left in this box. If the box has just 1 open row and 1 open column, just scan that for anything not in the box. So the 1 and the 5 don't help, but the 3 and the 9 do. And look what this 3 and 9 do. They take 3 and 9 out of all 3 of these cells. So where do the 3 and 9 go in this box? Well, I could quarter mark 3s here and quarter mark 9s here. But actually, there's something more powerful I can do. I can place a hidden pair. There are only 2 cells that can be 3-9, so those 2 cells are 3-9. And so that forms a 3-9 pair. Whatever we thought these 2 cells can be, they actually are only 3 and 9. Because if we put anything else in them, we won't be able to fit both the 3 and 9 in the box. So that 3-9 pair affects the column. It removes 3 and 9 from the rest of the column because they're down here, so they can't be up here. So this can't be 3, for example. And in fact, that does leave 3 to be one of these 2 cells. It does take 9 out of these cells, so 9 ends up over here somewhere. It also leaves a triple behind here. This is going to be a triple. We have 1, 2, 3, 4, 5. We need 6, 7, and 8. And that's not a 6. Okay. So this was really helpful, and actually just looking at filling this was really what was helpful, seeing this 3-9 here. So did we fill up any box columns? We did not. Did we fill up any more columns or boxes down to 4 or fewer? And then, yeah, this is down to 4. So we said we'd get back to it. This is 2, 3, 4, 8. This can't be 3, so this is 2, 4, 8. I think this can be any of 2, 3, 4, 8, so I'm not going to mark that. I was thinking about whether this had a triple or a quad, but it doesn't. This just can't be 1. Okay. Now this is down to 5, so we're not going to worry about that yet. I think that's what we get out of this stack. That was quite a bit. Let's move on to the next stack. We have this 5 and 8. We start there. We have the 5s are done. The 8 we already marked up. If we didn't, we'd do it now. The 3, 5, and 7. So we have all 3 of those. So these 2 3s look in. Putting a 3 in one of these 2. We have all 3 5s. And then the 7 look in. Putting a 7 in one of these 2. Any columns or boxes down to 4 or fewer. This is filled, but we already kind of took care of that. We already know everything about this box, and this being filled tells you about this box, so it's not worth looking at. I don't see any columns or boxes down to 4 or fewer. So we're going to move on to over here. The 5 and the 9. We do have 2 9s looking into here, so 9's in one of these. And then here we've got 2, 5, and 6. So we have these 2 2s looking down. This 2 looks in, so there's a 2 in one of these 2. The 5 we took care of. The 2 6s look down as well, putting a 6 down here somewhere. All right, any columns or boxes down to 4 or fewer? I do see this column is down to 4, so let's think about it. It needs 1, 3, 7, 8. This cannot be 1, so this is 3, 7, 8. It's not 7 either. So it's only 3, 8. 1, 3, 7, 8. Nothing else sees 1, 3, 7, 8. Okay. This column's down to 5. This column's down to a bunch. None of these boxes are helpful. All right. We do want to remember that these 3s were pointing down. So let's just check if that does anything at this point. It doesn't really seem to do a whole lot at the moment. It does mean that these are going to be down to 4 digits. The 3's up here. So let's actually think about that. So we need the 1, 4, 7, 8. So this can't be 4, 1, 4, or 7. Oh yeah, so we found a negative single 8. That is huge. So let's go over that again. This cell, let's make it green so we remember which one it is. It can't be a 1. It can't be 2. It can't be 3 because of these 3s pointing down from the box. It can't be 4, 5, 6, 7, or 9. So the only digit it can be is an 8. Now, of course, we don't really need to center mark that as an 8. We can just put the 8 in, because if there's only one digit it can be, that is the digit it is. That resolves this entire box. We get the 3, the 1, and the 8. That 1 resolves this whole box. We get the 4, the 1, and the 8. That resolves this whole row. We need 2 and 3. They go like that. And then that leaves a 4, 8 behind. We don't need the corner marks anymore. Very clean. There's a lot to follow up with here, but let's do the easy stuff first. I saw that also made this a 3. That gives us this 9 and 3. Whenever you put a 3 in the corner, this software likes to celebrate it. So it did. Okay. That 7 is now looking down into this box. It makes it much more obvious that 7 ends up in one of these 2. We also have a 6, 7, 8 triple here, which I don't think I actually used. I think I forgot to use that. That removes 8 from here, placing this 8, and it removes 6 from here. Because the 6, 7, and 8 are over here, so they can't be in the rest of the row. Let me explain that a bit further, because I often get questions about this. This is a naked triple. What does that mean? Well, naked means we're looking at the center marks. It means we're looking at the candidate list. The first question I want to ask you is, can we repeat a digit in these 3 cells? Like, can I do 2 6s? The answer is no. I cannot repeat a digit. Next question. What does that mean then? How many digits are going to go in these 3 cells? We're going to put 3 digits in these 3 cells. There's 3 cells. Each one needs a digit. They can't be the same. So we're going to put 3 unique digits. I need to be able to list 3 different digits that are going to end up in these 3 cells. What digits am I allowed to list? And I will say the only digits I'm allowed to list are 6, 7, and 8, because they cannot be 1. None of them can be 1. Not a single one of them can be 1. Not a single one of them can be 2, 3, 4, 5, or 9. See, they're all in this box here. So the only digit I can list at all for any of these cells are 6, 7, and 8. Well, that's 3 unique digits. So those are the 3 digits that are going in here. And if those 3 digits go over here, they cannot repeat in the rest of the row. They simply can't. Let's try it. Let's try to put a 6 here. Well, that makes this an 8. That makes this a 7. What am I putting here? I ran out of digits. We knew we would. We needed 3, and we only gave ourselves 2. So these aren't 6, 7, 8. So what are they for the row? Well, we need a 1, we need a 2, and we need a 4. And that one's not 4. This row is down to 2 digits. Whenever you get a row down to like 2 digits, or especially 1, right? Place it if it's 1. If it's down to 2, just look at that next. If you see it, look at it next. We know we need a 2 in this row. We need a 2 and a 6. This 2 tells us not here. So this ends up 2, and this ends up 6. That means this isn't 2, which puts the 2 up here somewhere. But that's okay. We don't need to mark that. There's now only 1 6 corner mark in this box, so that's where it goes. And we are left with 1 4 7 here. It cleans up a little bit, but does not resolve. Okay. This box is down to 1 2 4 9. 1 2 4 9. And this 9 tells us that it can only be here. So that's the 9. And then now this is down to, it can't be a 2, so this is down to 1 4, but it can't be a 4 either. So this is just down to a 1. Because we're down to 1 2 4 in the box. This can't be 2 and it can't be 4. So it's the 1. That's 2, that's 4, that's a 1. That's 7 and 4. We basically have finished the puzzle at this point. You kind of have to use your instinct. And when you think you're basically done with the puzzle, the easiest way to kind of finish it up is to look for rows, columns, boxes that have the very fewest open cells. Starting with this one, which has only 1 open cell. So we can just place it. It's a 7. This column is down to 2 open cells. Sometimes you can place them. Sometimes they end up a pair. Either way, it's helpful. We need a 1 and a 8. Looks like 1 and 8. So it's not resolved, but we get a 1, 8. This is down to 3 digits, including the 9, but otherwise it's the 3 and the 4. So 3, 4, 9. All right, these are down to 2. We need a 3 and a 6. And this one can't be 6. So this is 3, this is 6. We can clean this up a little bit. I am going to note that this 6 has a buddy looking in. This 6 looks down. So we can still do that. That's a 6, which makes that a 3. That's 8, 7, 6. We resolve our 6, 7, 8 triple. This one's not a 3. So the 3, 8 has to go here in the box. Okay. What's our low-hanging fruit? What? Maybe this column. It is down to 4, 7, 8. So this can't be 7 and that can't be 7. So the 7 goes there, placing that 7. And this is down to 4, 8. And this is down to a triple for the box, which should... Oh, it's not a triple for the box. Sorry. What's the other digit that goes here, though? It's the 2. So 2 goes in here, not there. How about this row, which is down to 2 digits? 4 and 9. This can't be 4. So this is the 9. This is the 4. We get the 8 and the 4 and the 8. That gets us the 1 and the 8. This is down to a 2, 9 pair. Let's just convert those corners to centers. This is not a 4, so the 4 in this row can only go here. That's 4 and that's 9. That's 2 and 9. We are left with 1, 2, and 4. We know where they go. The 1 goes here, the 2 goes there, and the 4 goes there. And we're done. Very nice. So we didn't even get through all our stacks and we finished the puzzle. May have gone even faster if I used these 7s here, but in the medium solves, I do save that. I feel like that's a little bit more advanced. I do save that for if we get through the entire first pass, then we go box by box looking specifically for stuff like that. So you can see some of my previous medium solves where I did need to do that in the past, but in this case I did not. So if you want to watch a more fluid solve where I'm willing to do more outside the box stuff, definitely look at my hard solves where I kind of take off the reins. I don't explain as much. I explain the things that I think are kind of unique to that puzzle or especially interesting about the puzzle. But otherwise, I kind of expect you to understand what my center and corner marking means, what pairs and triples are, that sort of thing, both hidden and naked. So yeah, hope you enjoyed this. If you did, then why not leave a like, subscribe, and a kind comment below.